In this video, I'll illustrate how we can use Denario to perform end-to-end scientific research. I'll also show how we can use Denario to write a full paper given some data. So this is going to be my working directory. Here I have a folder, which is the folder that I'm going to be working in. And I also have a code. Let me show you the code. We are importing Denario, then we are initializing Denario, and here we are telling Denario that our working directory is the project 1 folder I showed you here. We need to initialize Denario with some data description or basically an initial prompt. In our case, this text is located in the file called input.md, which is located inside project 1. So let me show you the file. Here we have a description of the data. It says that we have some data from a recent gravitational wave event. In this particular case, the data is contained in 2 different files, and these 2 files represent posterior samples from 2 different theoretical models. Then we're saying that each of these contains several columns, and this is the physical explanation of what each of these columns represent. Finally, we say that we're interested in understanding what the differences are between these 2 samples from these 2 different theoretical models. And here we are asking that it makes many plots, saves the data it generates, and indicates whether it has finished the execution successfully or not. So this is everything that we need to provide Denario with: the description of the data and the data itself. Let me show you an example of the data. These are the CSV files. Inside there are different columns like mass of the first source, mass of the second source, different properties, and there are many different rows. Every row represents a sample from the posterior. So that's it. This is our data, these 2 files, and this is our description of it. We can now run Denario. So let's do it. The first thing that it's going to do is read the description of the data, and then it will start to generate an idea. So you can see that right now there is nothing here. There is only the initial description of the data. And now it's created this new input file. And this is where all the files that it will create, all the plots, are going to be placed. It's generated this other folder called idea generation. There is an agent who, given the description of the data, is generating an idea, which you can see here. This idea is then passed onto another agent who is criticizing the idea. This idea, while superficially appealing with its buzzwords like manifold learning, is fundamentally underdeveloped and suffers from critical methodological ambiguities. So there is a criticism about this idea, and this criticism is passed back to the agent who created the idea, and this agent will then take this feedback and improve the idea. So you can see now that it's generating a slightly different idea, taking into account the criticism. All of these changes again pass back to the other agent who is still criticizing the idea. These 2 agents have this kind of back and forth interaction for a few times, in this case 3 times, and after, the idea will be created. So you can see now that we have the final idea here in the input files. The title is Characterizing Waveform Model Discrepancies in Gravitational Wave Posteriors via High Dimensional Density Ratio Estimation. So the next thing that Denario will do is it will check into the literature to see if any similar works exist. So you can see here in the literature log that it's finding some papers that might be related to this particular idea. And then given the abstracts of these papers, it's evaluating whether this idea is new or if it has already been realized. It's doing several rounds for this, and in every round, it's basically trying to find papers in the literature by getting their abstracts and analysing them. For instance, in the second round, it was able to find a total of 30 papers considering the previous interactions. And it repeats this a few more times. So far, it's analysed 40 papers, and it's going to repeat this for several rounds. This is in principle a hyperparameter that you can tune for your particular case, and it's searching the literature using Semantic Scholar. So it's making calls to Semantic Scholar API and extracting papers that might be relevant for this particular idea to be carried out with this particular data set. We've seen after 5 rounds that it has analysed 42 papers. And in round 6, it has concluded that the idea is novel. So if we return to input files, very soon you'll see a new file appear called literature.md, where it explains that the idea is new and shows how it's come to this conclusion. It reports the papers that are most relevant for this particular idea, explaining the similarities and the differences. So the next thing that it's doing is generating a research plan given this idea. Here there is a new folder called Method Generation Output, where if you look in detail, you can see that this is the research plan it has generated. For example, it says exploratory data analysis and data preparation, feature selection and pre-processing, density ratio estimation via neural network classification, and so on. And again, if you come back to input files and methods, you will find the research plan that it's going to use. The next step is, given the idea and the research plan, it's making a plan for how to perform the set of calculations that need to be done. And for this, we are using a CMB agent to implement a planning and control strategy. Right now, it's in the planning phase, and you can see the different steps that it will take in order to carry out this project. And now the planning is done. If you are interested, you can come to this file and you can see in detail the different steps that it will take. For example, load the files, check for missing or anomalous values, compute and save summary statistics, and so on. So once it's made a plan, the next thing it will do is write code for each of the steps in the plan, and then try to execute the code. So you can see that we have this control folder. There are 2 particularly relevant folders in here. The first is called Codebase. This is the folder where it will place all the different codes that it's going to write. You can see, for instance, that it's generated this code here. This is an entire code it has written by itself. So this is a function to load and verify data, calculate summary statistics, and here is the main function. The other relevant folder is called Data. This is where it will store the plots that it's making and also any other data product generated from doing the analysis. For instance, in this case, it seems that it has created some files to compute the summary statistics. These are the parameters that it's looking up, and this might look like some kind of mean and standard deviation. And you can see that it's also creating plots. For instance, this is a plot where you can see some distributions between the different parameters for the different models. And it's also creating other files that it might need later. So right now it's in step 3 out of 6, and now it's using neural network density ratio estimation pipeline. As before, it's going to write code, place it in this folder, and then execute the code. Sometimes it will try to write code and use a library. For instance, in this case, it was trying to use TensorFlow, but it turns out that I don't have TensorFlow installed in my system. This module is able to install the libraries that we need by itself. This part has finished, and it has produced this plot that looks like some loss function, the training loss and the validation loss. And now it's doing step number 4, which is the density ratio calculation and validation. As you can see, it has produced more files here. And it's now finished this step. And now it's going to do step number 5, which is high discrepancy region analysis and visualization. So the same thing as before, it's going to write code here and it's going to execute it. And the code will produce many plots, but can also generate files like this that might be useful for later to make a report. As you can see, it has created new code here. And it's also created this plot. And now it's doing the very last step, which is results synthesis and astrophysical interpretation. And what it should do next is take all the results that it has produced and summarize them. it has produced the final report for this part, summarising all the things that it has found. And now we've come to the final step, writing a scientific paper using all the results from the previous steps. It's created this folder called Paper, and you can see that the first thing it does is find the keywords for this paper. These numbers here indicate the iterations. So for instance, it tried to extract the keywords, but it didn't work. So now it's trying again. And it's going to do this several times in case that it fails. So in this case, it failed to get the keywords. This isn't a big problem since there are many disciplines where keywords might not be available right now in the way that we have designed Denario. Next, it will write an abstract. To do this, it will take all of the files that we have here, the initial data description, the idea that we've generated, the methods, and the results. And with all of this, it will write an abstract. We can see that it's already done it. Now it's writing the introduction. So we can open this file. This is where the paper is, and we can try to compile it to see if it works. We can now see that we have the title and the abstract. So it's still writing the introduction, and when it has finished writing the introduction, you will see that it will create a file here called introduction.txt. It should also now be here in the main paper, so we can try to compile it, and you can see that now we have the title, the abstract, the introduction, and it's going to continue writing in this way for the methods, results, and conclusions. I can remove all of these files as we don't need them. The system will compile these for us, so we don't need to do anything here. It's written the methods now. Next, it will write the results. Now it's finished writing the results. You can open any of these files and you can see that this is a normal LaTeX file. You can go ahead and compile it. So you can see it has all the tables. I'm going to remove all these auxiliary files that we don't need. Remember that you don't need to do anything. The system can compile everything by itself. So it's also written the conclusions, and now it's processing the figures. So what it's doing now for each of these figures is reading all the text that it's written before, together with the files that it has produced, such as the methods and the results, to write captions for each of the figures. you can see that there's a JSON file here, and this JSON file reports the different images. There is the name of the image, and then the associated caption that it has created for each of them. So now what it's doing is taking these figures with their captions and inserting them inside the results section. It has inserted the figures and it's now compiling everything together. So for this very first preliminary version, it's trying to compile it. It has produced this version 1 of the paper. And you can see that it has the title, the abstract, there is the introduction here, the methods, a table here. Here are the results, some tables, figures with the captions, more tables, and at the end here, the conclusions. So this is the first version of the paper. Now what it will do is improve the results section. For instance, for the figures, it's going to include references and make sure that the text reads well and everything is much more polished than in the first version. So you can see that it has produced a new results section and it has created version 2 of the paper. It has compiled it and we can see that it's essentially the same as the previous version, but in the results section we can find some references for the plots. For instance, here, figure 3, we have the reference to the plot. And let's see if there is another figure for table 2. Table 2. There we go. So that's it for this demonstration of how you can use Denario to write a paper given some data. And as always, it's really important to check everything, check the results, make sure that it makes sense and reads well.